I hope it's loading. Okay.
Yeah, it seems like we are live.
All right.
Okay. Hi, everyone.
Yep.
Welcome to Google Developer Space channel, and thank you for tuning in to our live stream today. A big hello to our friends watching on our YouTube channel and Facebook live stream on GDG Cloud KL. So do make use of the live chat to ask questions, which we will get to after the end of each speaker session. Before we begin, let me briefly introduce what we do and who we are. So Google Developer Space is a platform for developers and startups around the region to learn, connect, engage, and be inspired. As part of the Google Developer Relations team, we aim to empower and connect the community to our people, programs, network, and technologies, be it in person like a couple of months ago or online like today. So for today's session, we are very excited to be hosting GDG Cloud KL, led by Chi Seng. Thanks, Chi Seng, for bringing such a great line of speakers.
Hey.
Without further ado, I'll hand the stage over to GDG Cloud KL to start today's session. Over to you, Chi Seng.
All right. Thanks, Yasin. Thanks. So, first of all, we would, as a representative of GDG Cloud KL, we would like to actually thank Google Developer Space Singapore. So, thanks for hosting us online. And yeah, a little bit of introduction about me and GDG Cloud. I'm Chi Seng, one of the co-organizers for GDG Cloud KL Kuala Lumpur. And some brief, simple introduction about what is a GDG Cloud KL. We are basically a cloud community that is focused on promoting Google Cloud technologies through a lot of fun webinars, physical talk. It used to be physical talks, but right now we are all online. So you can watch it on your phone, on the go, anywhere. Just don't watch it in your car driving. So that's about it. And of course, today we welcome two of our very special speakers who will be talking about various technologies on Google Cloud. The first one would be Jonathan Lin, who will be walking through with us on the Cloud Tasks, Async in Cloud Tasks. And the second speaker is Jirayut Namsaeng, who will be actually giving us a brief introduction on Kubernetes and also GKE. So without further ado, actually I would want to invite our first speaker, who is Jonathan Lin. He's a consultant at Berlian Tech PLT, private, and his topic will be understanding cloud tasks for async tasks. So let's welcome Jonathan.
Hey, how's it going, everyone? So today my talk will be about understanding cloud tasks so that you can use cloud tasks to manage your asynchronous or background tasks or background jobs. I'm a cloud geek at johncloudgeek.com, whatever that means. That's just my technical blog. So let's just get into it. So what is cloud tasks? Essentially, it is GCP's fully managed service to manage queues, and the queues consist of background tasks or jobs. So what is a background task? A background task implies that when the end user or the requester is not waiting for the task to finish, you can actually take your time to finish the task in your own, take your sweet time to finish the task. The user is not waiting for the task to finish. So your application can actually take this opportunity to return to the user faster and do all these heavy tasks in the background later. So to give you an idea of what a queue is basically a data structure that can hold items. It can hold items. It goes in from the left, it comes out on the right, in generally speaking. So here we have a picture of two queues of tasks. Okay, so let's revisit what is a queue from your computer science class. If you remember your computer science class, it is a data structure and it is open at both ends. The item enters from the left and it exits on the right. First in, first out, that's a queue. So it does give us the following impression. Even the picture gives us the impression that it holds items in some specific order and it executes the items in that order itself. It's a first in, first out thing. Second impression it gives us is that the queue looks like it has a finite capacity. So in the picture above here, it looks like the queue can get full, and after that, who knows what will happen. And you would expect that if something enters the queue, it should exit only once. If you enter the queue once, you should come out of the queue only once. And usually this kind of queue is either, usually it's in memory, or it can also be persisted in a database. That's also possible. But in Cloud Tasks, all of these 4 points that I just mentioned are false. So your computer science class isn't lying to you. Usually this kind of queue is done in memory or in Java or in some programming language. But in Cloud Tasks, all these 4 things about the queue does not really hold, and let's see why. The first point is first in, first out. The actual truth in Cloud Tasks is that the queue in Cloud Tasks does not make guarantees of execution in any particular order. If task A enters first and task B comes in later, task B may actually be executed first. This does not apply to scheduled tasks, which will be executed at that particular time that you want. So do not rely on Cloud Tasks to execute your tasks in some particular order. It's just not going to work that way. Think of it as a set rather than the queue data structure. Secondly, usually queues have a finite capacity, but in Cloud Tasks, the queues can actually hold up to virtually infinite or infinity of items. But what is limited is the rate of processing that the queue can process the task. The rate of processing has its limits. And it's also not true that each task will be executed exactly once. And I think this is because at scale, it's just really difficult to achieve this kind of result. But in production, you can rely that 99.99% of your tasks will be executed exactly once. But of course, this is not really good enough. I mean, if your queue is in charge of payment processing, then this is really not good, right? So if you're using Cloud Tasks for a use case that is pretty serious, like payment processing, then you should probably add additional mechanisms to double check that your task it can be executed again, but it will not have any additional side effect. So maybe you'll need a relational database to double check whether the task really needs to be done again or not. So at that point, you may just want to use your relational database as the queue, right? Maybe you don't even need Cloud Tasks for that. So bear this in mind. At scale, some tasks may be duplicated. And it does not hold that all items are in memory. In Cloud Tasks, the queues persist the items, so that even if your application fails, like you just crashed, the server crashed, your tasks remain persisted in the queue until the next time you bring up the server again, you can start processing those tasks. So these are traits of Cloud Tasks that are good to bear in mind. It's not obvious at first sight when you read the documentation. So we have been talking about tasks. What exactly is a task? And my definition of tasks, I suggest to you, is that it encapsulates all the information that you need to do an independent piece of work. All right, a task is basically all the data that somebody else needs to do that work. And usually a task consists of the following items: a unique name, and this unique name is usually optional. If you give a unique name, then Cloud Tasks can help you to deduplicate the task in case you generate additional duplicate tasks yourself. So giving a unique name prevents that. But if you don't give a unique name, Cloud Tasks will just generate a name for you that is unique. Secondly, configuration information that is necessary to do the task, right? The URL endpoint that will handle the task itself, the timeout, how long are you going to wait for this endpoint to finish your task before you call it quits or call an error, or the HTTP method. Mostly you want to do a post to an endpoint, and that endpoint will do some tasks, right? And also you can also supply, lastly, the payload of data that is required to do the task, all the data necessary for someone else, the endpoint, to do that task. So a very basic example on a user creation, your application should ideally probably use something like Cloud Tasks to to generate a send email task, because sending emails can take 1 to 2 seconds of latency, and if you don't want to text the user like that, then you should generate a task, send email, and give all the data that is necessary to do the task. In this case, of course, the email you want to send, the template of the email, and all the mail merge key values that you want the email sender to merge into. So this is a very basic example, and if somehow let's say you use SendGrid, if somehow SendGrid is down at that time, this actually ensures that your email will get sent, even though the user created his account at a time where the API for the email is down. So that's just an example of the advantage you get with Cloud Tasks. So in order to talk further about Cloud Tasks, it's important for us to talk about App Engine, right? Some history here. So where did Cloud Tasks come from? So if you remember back then, Google Cloud started with App Engine, and it had this App Engine standard. We call it the first generation now. So App Engine standard first generation had this API called, the Task Queue API, which is essentially what Cloud Tasks is. So of course, moving forward to now, we have so many other things in Google Cloud. App Engine second generation, with Cloud Functions, Cloud Run, Compute Engine, or even anything else. Like if you want to run Cloud Tasks from your on-premise or if you're on your local machine, you should just use Cloud Tasks API, which is what I'm going to talk about more today. But the truth is, even though Cloud Tasks has its own API now and it's not in Task Queue API in App Engine, it still runs within the App Engine internal infrastructure. And the biggest consequence of this is that your queue location is essentially the same as the App Engine location for your project. So if your project has already App Engine pointed at US Central 1 and you suddenly decide that you want the queue to be in Singapore, you can't, that's just not possible anymore, right? Your queue is just locked into wherever App Engine's location is. And at the moment of this recording, you can't change the App Engine location for your project. You just need to create another project, all right? So this is something you need to bear in mind. It's really tied to App Engine under the hood. So your queue location will be the same as your App Engine location. All right, high-level overview. How do we actually use this thing? All right, you have your application, your API, your server. All right, it's trying to handle some user requests, and there's this particular task that isn't really critical to do right now, but maybe it can be done in a few seconds later. But we don't want to let the user wait a few seconds for you to do the task. So let's just create a task and throw it into Cloud Tasks, and then your application is free to return the user request. Okay, so what Cloud Tasks will then do is queue the task into its queue, the queue that you created earlier. And who is going to be doing the task? In the end, somebody's going to be doing the task. I'm going to call it workers, but Cloud Tasks calls them targets. All right. So there are two kinds of targets. One is the HTTP target, which I'm going to focus more on today. And another one is an App Engine target. And by the name App Engine target, it presumes that the worker is really deployed onto App Engine. Essentially, it's the same thing. I mean, it's still an API. You still use HTTP. But the difference is if you are deploying on App Engine, then you should use an App Engine target as your handler. But if you're deploying elsewhere, on-premise, Cloud Functions, Cloud Run, any server, even in some other cloud, then you should use the HTTP target, which is as generic as possible, right? It's just HTTP endpoint. So with the App Engine target, the additional benefit is that Cloud Tasks can actually control your App Engine service for you. And if you have way too many tasks in the backlog, it can actually auto-scale your workers for you. But of course, with the HTTP target up here, you will just have to do your own scaling and stuff. It's just separate from Cloud Tasks. So how it works is if you return a 200 or 2XX error, 200 error, 201, something like that, all will be fine, and Cloud Tasks will remove the task from the queue. If you return something else, maybe a 400 family error or 500 something error, then Cloud Tasks will basically get the message that, oh, the task did not complete, and it will not delete the task from the queue. It will actually retry again later, and it will retry with exponential backoff. And we'll take a look at what exponential backoff means. So, if you're not convinced how Cloud Tasks can help you, here's a list of features. One feature that's probably very useful is you can schedule some tasks to be done in the future at a specific time. And you can also manage how many tasks can be processed concurrently at any one time. You don't want to overwhelm your worker, right? So you can manage your delivery rates. Thirdly, you can configure retry behavior. How many times should we retry? How long should we wait between the retries? And how many, what's the maximum number of attempts that we should do the same thing again? And you can also actually peek into all the individual tasks in the queue from the Cloud Console or the Cloud SDK command line. And you can manage those individual tasks. And as earlier I mentioned, one of the components of a task is a name. And if you provide a task name, Cloud Tasks can help you to deduplicate tasks so that you don't accidentally generate duplicate tasks. So the use case for this is quite a lot. Like the user creation example, you can speed up the API latency by delegating some slow background operations, such as sending emails, to a worker, and then you can return to your user faster. Secondly, if you are using some third-party API that you depend on for your production use case, that third-party API is not in your control, and sometimes they're just down or just overwhelmed or just under attack. You just don't know, right? So you use Cloud Tasks to preserve your requests, preserve those tasks, so that it will be done later with retries. You will try again. And also, let's say, yeah, going back to the user creation use case, well, you show your service shows up on Hacker News, and you get everyone bombarding your user creation. And the good thing is now your server isn't actually doing the email sending in real time, right? That frees up your server to handle way more traffic than it could if it were to be sending emails by itself without Cloud Tasks. So it helps you to smooth those traffic spikes by removing those not so important tasks. Still important, remove it from the main flow. And thirdly, another interesting use case is maybe you are a data aggregator and you depend on a ton of APIs, and each of them have their own API call, API rate limit, right? So you don't want to keep calling them too frequently and end up getting banned or something. So you can use Cloud Tasks to manage those rate-limited third-party API calls so that you don't overwhelm them, and you can also retry if they fail. Okay, let's talk about configuring the queue, right? I mean, it's all in the queue, the magic's in the queue. So in order to talk about rate limiting, I think it's very important to talk about the algorithm that Cloud Tasks use in order to rate limit. All right, they use this thing called token bucket algorithm, which you can look up on Wikipedia, and which I'm going to explain now as well. So token bucket algorithm, imagine that you have a bucket, and every 1 divided by r seconds, basically at a rate of r, I put a new token, in this case a ball, into the bucket. All right. So if my rate is 2 seconds, if my r is 2, that means every half a second I'm placing a new token into the bucket. And the bucket, of course, is not virtually infinite like the queue. The bucket has a certain capacity. I call it B. When the bucket is full, like you're filling it up every 1 divided by r seconds, it will get full eventually. If it's full, then we just discard the token. It just doesn't enter the bucket, all right? So what happens when a task arrives? When the task arrives in Cloud Tasks, if it sees a token in the bucket, that token is removed and the task is executed, all right? So what if 10 tasks arrive at the same time and there is at least 10 tokens in the bucket? That means all the tasks that arrive, the 10 tasks, will be executed immediately concurrently. So it depends on the token in the bucket. If there's a token, you take it and run. If there's no token, you are subject to the queue. When a task arrives and the bucket is empty, the task is put into the queue. But remember that we are always refilling the bucket at the rate of 1/r, right? So every 1/r, when the bucket is empty, a task will be released. And that is basically essentially the token bucket algorithm. And having this algorithm in mind, it's much easier to talk about the configuration that we need to rate limit the queue. So there's this configuration called max dispatches per second. And if you don't know what I talked about in the algorithm section, you would think that, oh, it's going to be the maximum number of tasks dispatched from the queue. But actually, it's the rate at which tokens are being added to the bucket. So it's not exactly the rate at which tasks are executed from the queue. They are only equal when the task flow is steady, or if there's a huge backlog in the queue, then yes, your max dispatches per second will be the same as the rate at which tasks are taken out from the queue. So that's max dispatches. So max concurrent dispatches is the number of tasks that can be run concurrently. So your bucket may have 100 tokens. If your max concurrent dispatches is 10, then it doesn't matter if a new task is coming in and there's still tokens in the bucket. If there's already 10 tasks running at the same time and they're not done yet, then off you go into the queue. You know, there's just only the concurrency level is this max concurrent dispatches. So even if the bucket contains tokens, you can't execute the task immediately. So lastly, we have the max burst size, right? As you can imagine, your bucket size, the number of tokens it can hold, is the number of bursts, as in the number of tasks that can be executed concurrently, the theoretical limit, right? And this is actually not handled by us, and it should not be configured by you. Although there is a way to configure it using a YAML file that is not recommended now when using the Cloud Tasks API. So Cloud Tasks will intelligently set the max burst size based on your max dispatches per second. So you should not even touch this max burst size. Okay, that was rate limiting, right? So the second part of the configuration is retrying. You know, how many times should we try? So that is max attempts. So for example, you want to try at most 100 times and then just stop there, right? Or you want to retry unlimited times, that's also possible. Min back off is, so the first time your task fails, it will wait for the time of min back off. And after that, it will double the min back off time, and that will be the new back off time. And it will keep doubling until it reaches max back off. And after it hits max back off, it stops doubling, and it will just be continuing the interval, the retry. The retry interval will be max back off after it hits this limit. And max doublings is the number of times the back off time doubles. All right, in this case, 16. I think that's the default. And besides the attempts, number of attempts, you can also specify and state how long should you be retrying. So for example, 7200 seconds, that's 2 hours. So you want to retry for 2 hours and then just stop, regardless of any other setting above. So these are the parameters that you get to play with when you design your queue, when you want to improve your queue's efficiency. So this is the parameters. Okay, it's time for a demo. And this demo is going to be a really contrived use case, but I think it's going to be quite helpful to understand what's going on. We will have two cloud functions. And the first cloud function is a task generator. In fact, that's the endpoint, task generator. Task generator, all it does is creates tasks in Cloud Tasks. And every task has a payload that consists of A and B, two numbers. Two numbers which the other task handler function is just supposed to add up and print to the console. Very unexciting, all right? A function to generate the task and another function to handle the task. So here's a demo checklist, mainly for me. Okay, so first up, let's take a look at the task generator. So as you can see there, I require the library, the Cloud Tasks API, Cloud Tasks SDK library for Node.js. And I can configure a task count, the number of tasks that I want to generate from the environment variable. And by default, it's a post. And I can provide a task endpoint that is also configurable from an environment variable. And as mentioned, I'm going to generate two numbers, A and B, randomly. And since there's a payload, it's going to come here. And this is the part where you just need to accept the sample code and run with it. Basically, you need to provide a string, and it will somehow convert it to a buffer that is in base64 format. And it's also very important to, well, I think I lost an hour here. If your handler is expecting JSON, then the HTTP request headers should have content type of JSON, application JSON, okay? So this is a service account email, which I'm not going to demonstrate right now. Later, I'm going to use this to generate a token for authentication. And subsequently, once you have the tasks all built up and ready, we will just call it with the correct queue and create the task. Let the client library create the task for us. So as you can see here in Cloud Tasks, there's actually no button that says create tasks, or yeah, basically everything is done through the command line. So let's wait a bit for my shell to appear. Great, it's kind of big. So let's shrink that a bit. Okay. So let's create a new queue, gcloud tasks queue. I think that's queues. Create, and let's call it GDG demo. Okay. And in order to inspect the queue, what we can do is describe it. So you can see that this is the queue path. And all the configuration options which I mentioned earlier, especially the burst size, the concurrent dispatches is pretty high. And the max dispatches per second is also pretty high. That's fine. And the retry configuration, number of maximum attempts, 100. Min backoff, 0.1 seconds. It doubles 16 times. So if you do the math, actually, 0.01 times 2 to the power of 16, it gives you a roughly 6,500. But before it actually manages to hit 6,500, it stops at max backoff, and that will be the limit of the backoff. So what I'm going to do now is use this new queue that I just created and put it into my task generator. So my task generator has been configured already, and it has this task count, task endpoint that's pointing at the other function. I'm going to change this right now, and this one I'm actually going to remove it. So I'm just going to remove this. I'm going to change queue path. So I'm removing the service account endpoint because I don't want to generate a token right now. So I'm going to deploy. And another thing I want to point out to you is I created a custom service account just for this function. It's called task generator. And I believe if I click here, I go here. Okay, so the permissions that this task generator has. This task generator has, let's just use generator. So this task generator has the two following roles. task enqueuer, which basically allows it to enqueue tasks. And secondly, it has service account user, which we will not use at the moment, but when we provide a service account email, it will use this role to generate the authentication token. So that is the roles that this service account has. And I think we are deployed, so that's 8 o'clock. And let me go back one step. And there's another one, there's the task handler, and right now it does not allow unauthenticated calls. So for now, I'm just going to make it allow unauthenticated calls. And the way to do that is, well, first of all, I'm going to remove this. And secondly, yeah, the UI is not great, but you check here, you show info panel, you add member, and all users. You allow all users to invoke this function. So basically, that will make your function public. And now you have both functions unauthenticated. All right. So I'm now going to go to Insomnia. And I want to show you that the handler works. Okay. So the task handler, given two numbers, will add up the two numbers. So hopefully it'll give me back a result. Great. So the second one is a task generator, and it's now completely public. I'm just going to let it do its thing, generate tasks, and it says OK. It says OK. And how do you know what has happened? So if I go to the logs in the task handler, I should see a bunch of logs that print out a result. And it's a bit tight in here. Let me get rid of some stuff. Okay, so it's 802 now. So the function has received A and B and computed the result and returned it. And I think I forgot to show you the code for the task handler, but as you imagine, it's just A plus B, right? And then return. Okay, so the Cloud Task has done its job. It has ingested the queue, and it has processed the task. So right now, there's no task in queue. Not very exciting. Okay, so now to make things a bit more complicated, I will go back to functions, go back to the task generator, and I will set the service account email. So and that's it. That's it. Okay, let's wait for the deployment. And as for the task handler, I'm just going to remove this public access so that the task will fail. All right. So let's just go to permissions, and right now all users can invoke it. I'm going to delete that. So if I go back to my functions page, all right, task handler is now a private function. And hopefully to prove that, task handler should fail. 403. I think it'll take a few seconds to work. Hope I did something right. Yeah. So there is some lag time when you're dealing with IAM stuff. Hopefully I'm not doing something wrong. Okay, refresh. Okay, it's still handling my tasks, which is weird. Let's try to trigger it manually. Still working. Still working. Okay, anyway, let's just move on to the demo. So my task generator is still public. So I'm just gonna go ahead and create tasks right now. And let's see if it managed to handle. Let's so what I'm hoping to see is that the task will remain in queue because it's failing. And looks like right now it's finally failing. All right. Let's just sanity check. Are you failing? Yes, great. So there is some lag time when you change Cloud IAM stuff because caching. All right. So it's failing now. It's saying, okay, we'll retry. We will retry sometime from now. And it's basically backing off. And you can actually see what's in the task. All right, these two numbers. And so let's fix the problem. Let's go back to the function. And in the task handler, we need to give the task generator at, come on, autocomplete? No autocomplete. So let's just go there and grab that thing. Actually, it's task generator, but I'll grab this, fine. Let's see, task handler. Okay, and then check this, add member, and task generator. So task generator is the one that should be given the role of invoker because the tokens are coming from task generator. And hopefully it won't take too long this time for it to work. And once it starts working, you will see that the queue will slowly be drained. So in 15 seconds, we will try again, and hopefully it will drain the queue. Otherwise, we need to wait an exponential back off. Let's open the logs. And right now it's 808. Okay, just nothing yet. Okay, so it's going to wait another 1 minute, and instead of waiting, let me jump to something else. Authentication. Okay, essentially what I'm hoping to see, which we will hopefully see later, is that the endpoint is working again. It is authenticated, and the task queue will be drained. Eventually, it will be drained. So while we wait for that, so let's talk a bit about securing task handlers, right? Just now we saw the task generator providing an OIDC token that is tied to a task generator service account. And on the receiving side, we have that task generator having the role of cloud functions invoker. And just like that, Google Cloud has managed to secure the authentication between the caller and the receiver being the task handler, which is really nice because we didn't actually write any code to authenticate the token, right? You didn't see any code about token at all. So that is the first way you should try to use when securing your handlers. Generate the OIDC token on task creation and validate it in the task handler. And if you use Cloud Functions or Cloud Run, you're in luck, right? Cloud IAM does all the magic for you. It does the authentication for you. But if you validate the token yourself in some other non-serverless application, then you will need to invoke those OIDC libraries to validate the token, and it's really not covered here because I haven't figured it out actually. So yeah, not so nice if you're not using Cloud Run or Cloud Functions. The other option to OIDC token is OAuth. You can also use OAuth token, and it also supports scopes. And the really simple, stupid, if you just want to get it done right now, if you don't want to validate the OIDC token yourself, is, API key here, API key there, and they match, and somehow they are authenticated. Not recommended. Google Cloud won't even document this approach. I'm telling it to you, but don't quote me, right? MIT license, commercial use, but no liability. Okay, let's go back to the queue, and I think it will be drained by now. All right, so the authentication is happening, and the retries have finally succeeding. So the task is no longer in queue because it's done. All right. Okay, so a valid question would be, well, I know about PubSub. Today I learned from you about Cloud Tasks. So what's the difference? Difference is somewhat philosophical. In Cloud Tasks, the publisher knows about who is going to call, right? The invocation is, I think I swapped these two around. Okay, so Cloud Tasks is actually this one. The publishers explicitly call the endpoint, and the control remains on the caller. Whereas for PubSub, the publishers do not need to know anything about the subscribers. The subscribers do not need to know anything about the publishers. It's just an implicit relationship. All right, so I got these two mixed up, but yeah. So for Cloud Tasks, we have the benefit of all the features I showed you earlier, which are not supported by PubSub. And first of it, you can schedule delivery times. PubSub, there's no such thing. You can configure your delivery rate. You can configure your retries. Well, yeah, you can kind of configure how long PubSub keeps your message around, but you probably can't configure the amount of time it waits. I think PubSub is less patient and just keeps trying. The duplication of tasks. So what's not supported by Cloud Tasks? In Cloud Tasks, you can only create one task at a time. Right? If you want to create 10 tasks, you have a for loop and you just create one at a time. In PubSub, there's actually an API to create 10 in one go. Okay, and you can actually have multiple subscribers listening in on a message to basically you get multiple handlers. Only in Cloud Tasks, you only get one handler. And the max size message in PubSub is very generous, 10 megabytes. In Cloud Tasks, it's only 100 KB. There's no upper limit to the delivery rate. In PubSub, it's really for big data. In Cloud Tasks, you're limited to 500 queries per second per queue. And okay, PubSub is a global service. It is immediately global. Whereas Cloud Tasks, as I explained earlier, is tied to your App Engine location. Another comparison usually made is Cloud Tasks versus Cloud Scheduler. This one's a bit easier. So Cloud Scheduler is a cron periodic scheduler. It triggers based on time. Cloud Tasks triggers based on your code, your actions from your user that triggers that code. And Cloud Scheduler basically just fires and forgets. It does not retry. You either catch it or you don't. All right, but Cloud Tasks retry. So it's actually two very different things. And usually you would probably want to have a Cloud Scheduler trigger that generates a bunch of tasks that will be handled by Cloud Tasks. So these two usually work together instead of one or the other. And just in time for Q&A. And while we wait for the questions to flow in, just would like to tell you a bit about my Google Cloud newsletter, which I publish every 2 weeks, and my technical cloud blog, which you can visit to read on some blog posts on Google Cloud.
Right. Thanks, Jonathan. Once again, thank you, Jonathan, for the talk. So actually, we do have questions for you. It's actually 2 questions in one, but okay, I'll figure that out. Right, sure. The first one would be, does Cloud Tasks support with App Engine flexible environment as well?
That's a very good question. I believe that it is for App Engine standard only. I could be wrong, but let me get to you in the comments again if it's in the comments. But I believe it's App Engine standard, if I'm not wrong. But I could be wrong, actually. Yep.
Okay, so it's actually from the same guy. It's from VNode as well. Secondly, is that can I use Cloud Tasks to trigger a web app running on Kubernetes cluster based on some event asynchronously?
Can I trigger?
Can I trigger a web app running on Kubernetes cluster based on some event asynchronously?
Yeah, so I think maybe you want to, there's a cloud scheduler trigger that runs periodically. As long as your endpoint has to be accessible in some way to the public, right? I don't think you can reach down to some gRPC level. It's going to be HTTP. And of course, you want to do some authentication with your Cloud Task Handler. As long as it's accessible through some HTTP endpoint, you can definitely use Cloud Tasks to handle your worker queue. Yeah.
All right. I think that's actually all of the questions from the comment section below. So yeah, guess once again, thank you, Jonathan. So if you guys have any more questions, you can actually leave on the comment section below. And if you're watching on YouTube, yeah, you can also leave a comment section below. Then we'll try to answer it. So yep.
Thanks,
Let's
guys.
move on. Right. Thanks, Jonathan. All right. So the next speaker would be Jirayut. So what he will be talking about is introduction to Kubernetes and also GKE. So without further ado, let's actually welcome Jirayut. Hey.
Hey.
All right, take it away.
Okay, it's my time round. Okay, thank you so much for opportunity for this session. So thank you again for the Google Developer Space and also the GDG Cloud KL that invited me for this session. So basically, this session I will talk about the introduction to Kubernetes and GKE. So basically, it will be the beginner session for whoever that okay, what is the Kubernetes and what is different when we are using on the Google Cloud that we name it the GKE. So I will explain all that. So let me introduction myself first. My name is Jirayut Namsaeng. Currently, I am the founder and CEO of the Upstart Thailand, and basically we are the DevSecOps transformation consultant for the. Okay, sorry. Okay, basically we are the DevSecOps transformation consultant in Thailand. And yeah, I just being the GDE Cloud based in Bangkok since the beginning of the year. And then, yeah, we know all about the COVID-19. And I can say that this is my first event as a GDE Cloud talking here. So yeah, let's see. So today we will talk about the everything about the Kubernetes, but actually I want to start from the basic, from the started from the cloud, and then we will talk about the like a virtual machine. Yeah, someone heard about this for a very long time. The container and Docker. Someone that still don't know that what is the difference between the container and Docker. And then I will talk about the Kubernetes that, okay, what is the difference from Docker? So it is if we use the Kubernetes, so we won't use a Docker anymore, or we have to use it together. So I will explain in this session too. And then I will walk through you to the Kubernetes architecture, and then I will show the benefits of using the Google Cloud, the GKE, and then I will show you the Kubernetes basic concept like the pod, deployment, service, And then while I explaining on each concept, I will show you the demo, the real demo from the Google Cloud Console. So you will understand more on this. So while I explained about the concept, I will show you the what exactly how it is doing. So yeah, let's get started. So I want to start with it's like as a developer today, we have a lot of technology to learn. But for the infrastructure, we call the model infrastructure, we have to learn all these three things. Yeah, I recommend that everybody right now you need to learn about these three technology. First is about the cloud. Yeah, whatever it is a private cloud, public cloud. Yeah, you have to have this skill on your IT industry. The second thing is about the Docker, the container. You have to know what it is. You have to know how to build it, how to run it. And the last thing, if you want to build the scale infrastructure, or even you want to build a high availability of the container of the cloud native platform, you have to learn about the Kubernetes. So let me walk through to this on each one. First, I want to talk about the cloud as a service model. I think that maybe some of you may be seeing this before. This is like showing all the structure. That's what we call the cloud, and we separate it as a service model. That okay, how you taking care of each infrastructure. For example, on the left side, you will see the private cloud, and with the orange, you have to taking care of all the layer from the networking, storage, server, visualization, OS data, and application. So everything you have to taking care of by yourself. Why? When you see the infrastructure as a service, that okay, if you back in the 5 years ago, we will see this a lot of popular, and everyone using it when the public cloud is coming. The public cloud show them that we show them the infrastructure as a service. So you want to have taking care of the network, storage, server, and visualization anymore. So it means that okay, you just have the the dashboard that you're going to create the virtual machine by yourself, and then install everything by yourself. So you just looking at okay, you can scaling, you can creating anything on the cloud. So you only taking care on the OS data and application layer, and then we evolve more on the platform as a service and the software as a service, that the developer you don't have to have the cognitive that you have to taking care okay, for the OS, why I have to care about okay, do I need to use the Linux or the Windows, or even which Linux like CentOS, Debian, Ubuntu, or yeah, anything else. I just want to write the application, it's right. Or the developer want to just focusing on the writing code and the database, and then that's it. Everyone want to use it. That's all. And the last one is a software as a service, that okay, everything have to you don't have to own anything. You just buy it or rent it, and then you using it. But on this, my point is I want you to focusing on this platform as a service, or PaaS, or PaaS, because this is the future. Last few years, people focus on the infrastructure as a service, but right now, every service going to be the platform as a service. For example, like the serverless, the cloud function, the Google App Engine, and even the Firebase that is a backend as a service. So it's been the variation of the platform as a service, and this is a future that we are going to. And then I will explain you later in the later slide that how Kubernetes matching for the platform as a service. So yeah, let's go to the next slide. For in this slide, you will see virtual machine, container, and Docker, how different it is. Someone didn't know that the virtual machine, it is exactly just a concept. The concept to like the emulate the infrastructure, just like the CPU, the memory, the hard disk, the networking. So it's virtual machine concept is about the emulate thing, but for the container concept is about the like build a prison for to limit the resource for us. Just like okay, we have a machine for the like 8 CPU with the 16 memory, but for this container you can only see like a 1 CPU or the 2 gigabyte of the memory. So basically it just build the wall for the container to see the resource limit that we want to. So for this is different between the concept of the virtual machine and container. So they have a lot of software to implement this concept. So basically for the virtual machine, we can heard about the VMware, the ESXi, or even the open source called the KVM. But for the container, actually we have a lot of software that implement the concept of the container, for such as the OpenVZ, and we have like the Jirayut, and we have the LXD, LXC. All of this is implement the container concept. But now the Docker is the most popular container platform that every developer, everyone have to use it. So my point is the container, the Docker is try to implement the container concept, and then it's being the most popular software for the container platform. So I got a lot of question about the container going to destroy or the virtual machine world or not. I can say that in the future, VM won't go anywhere. It will stay together like this, like the picture I showed you to you. You will see here. You will see that this is a machine, and then you will see the VM. We still have the hypervisor here, and then we have the like a Docker run inside the VM. So in the future, we will have the VM stay along with the container together, and then in the future, we still have VM running like the database in production. That I encourage you to still using this on the VM, but not container yet, or the legacy system that it's still we need to run on the VM. So in the future, it will stick together. Now you have to know the concept on this about the build, ship, run. That's it is the main concept of the Docker. The Docker building this concept, build, ship, run, and made it popular because, as you can see here, you can see the build. The build is mean that you can build anything with the Docker. Specifically is a Docker file. So you will see like previously, like the last 5 years ago, when people want to install something like the PHP developer want to run the PHP and the MySQL on their laptop, they need to like a file tutorial and then install, and it will take like a whole day to just just to build a development environment for them to develop the PHP. But after the Docker come, you can just like go to the Docker Hub. That is basically is a registry here, and then it means that on the Docker here, people already built people already built everything for you, like a PHP, and you can choose any version you want to install, or the MySQL to install, and you just run one command here on your laptop. You just run one command like a docker run PHP, the docker run MySQL, and then you get your own environment to develop very fast, just like only a few minutes, and you can write a code at a time. So for the Docker, is create the concept about the build ship run that we can reuse any of the software that people on the whole world build together, and then they ship on the registry here. So you can pick anything that people in the whole world build for you, like Node.js, PHP, MySQL, anything that you can run. And then the last thing is about run. You can run anywhere, just like you can run on your laptop, you can run on the server, or even you can run on your cluster of the server that I talking next. So now you know about the concept of the Docker right now. So I will go next to the next thing about the Kubernetes. The Docker is about run on the standalone server. So it means that if you want to run container on any node is mean that just like on your laptop or even on your server, it will basically fine. I mean, basically you know exactly where it is run. But the problem will come when you will see the container here. When you have multiple servers, just like here, the problem is 3 nodes. How do you know that which container, which node that you are going to put that container on? Which node that still have the resource left for you? Which node that if I deploy this container onto this, how can have the load balancer that have the load balancer to forward the traffic to the node that have this container on? So this is all the problem about that the Docker that cannot the Docker cannot solving for you. So this is come to the Kubernetes. The Kubernetes for this, it's all basically all the Kubernetes. But I want to tell you that the Kubernetes is the cluster management. So the Kubernetes is not the container itself, but actually is the here you can see the helmsman for the containers. So it means that it will control the container for you when you have the multiple ship, or you can say we have the multiple servers. The Kubernetes will taking care it for you. So it means that it will see the whole thing, and then it's going to doing the schedule for you. Okay, this is we have still the resource left. It will put the container on this server for you. So basically, it's manage the cluster for you. So it means that it will answer the question that if I using the Docker, do I need or no? I mean that if we use Kubernetes, we'll still need the Docker. I can say basically is yes. But Kubernetes and can do more than that. Like the container nowadays we have a lot of the container platform the new container platform like the CIO, the Podman. So Kubernetes going to manage all the container software. So so the point is Kubernetes is a cluster software and looking after for the container. So I already talking about some of the key feature about the what Kubernetes does. Just like the automatic bin packing, it is about automatic bin packing is about scheduling. That's okay. We have the 3 containers or three servers, and then okay, which server have enough resource to put this container on. Which server is already full, so yeah, it will schedule and see the best resource to put the resource to. It even have the self-healing that I will talking later on the deployment concept of the Kubernetes. It will have the auto scaling, the service discovery that I will demo about half of it on this today. So let's start first with the Kubernetes architecture. Actually, the Kubernetes architecture is very easy. You can see it's only separate on 2 components. First one is about the Kubernetes master, and the other is about the Kubernetes nodes. So it just have the 2 components. And it's really easy to understand about the okay, the Kubernetes node is about the workload. Every container running here, so it means that all the workload like the application or the development application that you wrote, it will deploy on here. And for the Kubernetes master, it will do all the feature that I put in on here, okay, when I will see which the Kubernetes node is still have free of resource, and then I will put the container here. It will ordering the Kubernetes node to do what it said. But in overall, Kubernetes master will look after all the node here. So for this, you will order it via the API. But for the API, you can using the user interface or the GUI, or even you have the command line interface that I will show you both on the demo today. But this feature is really important because you will see exactly on the 2 separate things that made the Kubernetes is the platform as a service. You will see on the right side here is about the workload. Here is about the infrastructure. If we going back again, Kubernetes is all about this. You will see Kubernetes is doing the network, storage, server, visualization, or even the OS for you. So in the point of view of the developer, you don't have to looking all of this. The responsibility is about is on the operation team or the infrastructure team. But for the developer, you just putting order the command to the Kubernetes API, and then it will following your order that I will demo show you today. Okay, I want to deploy the NGX. I want to deploy the Apache. I want to export this into the public IP, and then we can access it. Something like this. So it means that okay, you don't have to know about anything about which OS is installing on, how many VM we have to create. It's just doing everything it's doing everything for you. But for this, I can say it is really hard here to building the cluster by yourself. I mean, like okay, you have to buy the physical hardware, or even I build a lot of the Kubernetes master on premise. Is mean that you have to build a bunch of set of the hardware, like a network, firewall, the server, a lot of it. But I will talk next about the Google Kubernetes engine, or the GKE. So I already emphasized on what GKE did to you on this. GKE going to manage, you will see here, going to manage all your environment, or your the server, or your the network, or your the security, or your the firewall, using Google infrastructure, and it uses a compute engine, and then it's group it together. So basically, it means that you don't have to looking at the complex system here anymore. It means that you just doing like the one click, and you create the complex system, the complex Kubernetes cluster for you. So it means that Google already taking care all the all the infrastructure for you already. So if you are using the GKE, it means that you will see you can just use a single click command to create high availability cluster, and everything else that I will show a demo to you today. So let's go. Let's see. I am going to create the Kubernetes cluster with just one command. So let's see how we can create a cluster. So you have two ways to create a cluster for you. First one is about using the command line, like a G-Cloud container cluster. I'm going to create the cluster called the GDG demo with the nodes, with the 4 nodes, and then I'm going to put it in the Singapore zone. Yeah, just one command here. Oh, I need to set the project first. Okay, remind me. Okay, creating again. So we just put this one command, and then we're going to look at the Kubernetes console here, and then trying to refresh this. Okay, and you will see that the cluster is building right now, and it takes you only a few minutes, or just no more than 5 minutes. You have your whole cluster, and you can see the cluster size is 4. It means that it's only build the worker node, the 4 worker nodes for you. So we have a lot of option here to create the cluster, and the Google Cloud is done it for you. So let's see each option. Just like, okay, you can choose the high availability cluster, like for the whole zone, or even you can use the whole region. It will build the Kubernetes cluster across all the 3 zones on each region for you. You can choose the version of the Kubernetes here, and you can upgrade it later with just a single click on here. And if we go to the you can choose the spec of your node, like okay, choosing the spec or the CPU you want, or the memory you want. You have the option, a lot of option here. So okay, oh no, number of the nodes, where it is. Oh, it's here. Okay, and you can choose the size. Basically, it's a static size. It means that, okay, you're choosing how many nodes you want to build, and also you can have this option that's that it will do the auto scaling for you. You can pick like, okay, on the really low load, we have 3 nodes, and then in the very high load, it can expand to like 3 to 9 nodes, something like this. So this is the benefit of GKE, that it will did it for you. Or even on the security side, just like, okay, you can have the public cluster that everyone that have the credential can access, or even you can create a private cluster that everything is internal IP, that it will cause more secure to your cluster. And we have a lot of options here that you can customize with the help of the Google Cloud platform, that it will did it to you. So basically, let's see that is it going? Yeah, it's still creating. So yeah, we will leave it there. So today, for the introduction, I am going to walk through you all the basic concept here. Yeah, but some maybe it's really hard to understand, but yeah, I will try to demo you to to make you more understanding on each concept. So at first, I want to show you the first thing about the Kubernetes. Actually, you can create the resource. When we create something on the Kubernetes, we call it resource, and we have kind of the resource. You can see on this line, you can see that we going to create resource kind is pod here, and then all the spec is all about this that I will explain you later. So basically, it's all about the manifest file here. And next thing, I'm going to create on each concept. I am going to walk through the concept and create each resource type to show the demo to you. Since it have two ways to create create the resource on the Kubernetes cluster. This is a way that I encourage everyone to create the resource on the Kubernetes cluster. I mean that when you create the manifest file, that it will explain everything on you want to create on the cluster. This is what called infrastructure as a code, or the IAC. So it means that you can put this on the version control, and you can see that for this on the version control, you can see all the change. You can see the record change. You can get it rollback or anything on this. So I will quickly walk through to the each concept for you. Okay, I'm seeing the time. Maybe we cannot walk through all the things here, but yeah, I will try my best. The first thing is about the pod. Pod is the smallest thing that we create in the Kubernetes cluster. I can say that people may be sometimes confused about that. Okay, is a pod equal container? I can say that, okay, most of it, the one pod is equal one container. I can say that most of it, like more than like a 60 or 70%, we have one pod equal one container. But actually, we have a lot of use case that we have multiple container on one pod. So basically, pod is the smallest resource thing that we are going to create on the container. So let me show you to create the pod here. I'm going to show you here about this is the manifest file, and I am going to create a pod here named Linux. Yeah, for here it's named Linux, and it will have the two container here. One is a BC-box that using the Linux BC-box, and the other is Alpine. So I am going to create the two container here. So basically, okay, the cluster is finished. So I'm going to create a cluster here. Okay, so at first I'm going to create with the command line. It's really easy to create, just like here. Oh, okay. I need to get credential for this first. Okay, I'm going to authentication with this. Okay. So is okay. Oh, why they have a lot? Okay, I'm going to create the first pod here. Just applying this, apply the manifest file here, and then it's showing here. And then this is a benefit of the GKE that did it for us. It have their own GUI, and you can go to like the dashboard here, and you will see here. You can see the Linux pod is already run. So actually you can do the command line to get the pod here too. You can see the Linux here. So basically the container is already run on the cluster, and you can see that we only take like the 5 to 6 minutes to run the first pod. So I want to go to the next thing about the next concept is about the deployment. The pod is an individual. It's with that is working by itself, but it cannot take care itself. It's with that if pod is if something wrong is going with the pod, it's it's like it's going to have the effect on this. So it's mean that no one going to take care of it. Just like okay, if this node is going down. You have to move pod to another node. If you only use pod, it's not going to take care of this for your for your cluster. You have to create the deployment here. The deployment will it's going to take care a cluster of the pod. So basically, if we have here, we have the replica. At first, we set it at 1. And then we're going to change like okay, we change to replica to 3. The deployment going to take care the pod on the every node to scale out like this, to scale out to 3 on the each node, and it's going to find the node that have enough resource. And its deployment is going to take care for the self-healing for you also. Like okay, if this node is going down, what happened? The replica is not 3 anymore. So it means that it's going to create another pod on the rest of the nodes. But what happened if the node is going down? Node 4 is going down also. So it's means that it's not 3 again. So if it have enough resource, it's going to do something like this. So its deployment is taking care all the pod that okay, I'm trying to make a state as we config in the replica here that it is 3. So let me show you the demo here. We have the deployment here. You can see this is a Kai deployment. This is a Kai pod. So basically, the Kai deployment here will have much more configuration than the pod manifest file. You can see we have the replica here that I config as 1, and then we have the container spec like the pod here that I'm going to use the Nginx here. So I'm going to apply this. Okay. So when I apply, so you will see here, Nginx going to create a pod with the hash name with a hash name, because the deployment already taking care of it and it's random generator the hashing ID for the pod. If you get to see the deployment, you will see like, okay, the Nginx going to create 1/1, so it's going to create one pod for this deployment. And let me show you, this is a pod, right? This is a pod. I'm going to deleting this. Delete pod here, and you will see what will happen. Okay, take some time, but I will get pod again. Let's see. You see, this is not the same as the pod before, but what happened is the Nginx here is already deleted, but the deployment already create another one for you. Just like if a node have something wrong with the nodes, and then it will going to create another pod that actually working for you. And also for the dashboard, we can scale, like manually scale as much as you want. For example, okay, we have 4 nodes right now, right? I'm going to scale here, you see, and I'm going to scale this to like 4 and scale. And then let's see what happened. It's going to scale, so I'm going to get pod again. You will see the Nginx is scaling to 4 container is container creating right now. And this is a deployment. And the last one, the last concept for today, I think that's this is the last I can talk about. It's about the service. The service is, you will see it here. Okay, this picture first. When you create the pod or deployment, it will create random IP address that no one can access it. If you want the pod, or even we can call the application, when you write a application in the container and you want the other can access it, you have to create the service resource on the Kubernetes as just like a logical load balancer for the pod, so people can access it via the service. So to see what am I going to create service next, the service we have about 4 or 5 types. I couldn't remember, but I am going to create two of the service type to show you example. First one is about the service, the load balancer here, and we have another type is the cluster IP. This is the benefit of the GKE. The service type load balancer here, you cannot do it without special plugin like you cannot do it on your own server on your premise, because when you specific type equal load balancer, it's going to create the cloud load balancer on the on the Google Cloud platform for you, and then it's request the public IP. So it means that okay, I already create the Nginx application server. You can export the service, export the Nginx to the public instantly. So I will show you again. Let's see here. This is a service. This is you can see it is a resource called high service, and the service is named Nginx, and you can see here a specific type of this service is a load balancer, and then it's going to export port 80, and it's going to select the app equal Nginx that is here. You can see the label. The label here is app Nginx, so it's matched exactly here. So next thing I'm going to apply this. okay, and get service, you will see the service Nginx is creating here, and then you will have you have your internal IP that's called cluster IP that the external people cannot access in this except the port inside your cluster itself. And you can see here, external IP is a public IP that the Google Cloud will going to assign by itself, but it's still showing pending because it's still requesting via the API. But if we waiting for like for the a minute or few minutes, it will getting the IP address here, and then if we are trying to access this, you will see the Nginx here. So to show you that it is exactly that Nginx that we deploy, I'm going to delete the deployment that we deployed before. Okay, let's just see. I'm deleting this and I'm refreshing this, and you will see it won't work anymore because we don't have Nginx. But if we put it back and give it some time, okay, it's running right now. It's going back again. So this is very easy to, if you use the GKE, it's very easy to deploy the application. If you already prepare, like your application as a Docker container, and then put it on the a Docker registry or even the cloud registry on the Google Cloud platform. So this is all about introduction. Actually, I still have a lot of I want to demo too, but yeah, I can say one thing for the wrap up for the Kubernetes. I can say is Kubernetes is hard. It's really hard, and they have a lot to learn about. Just like I just show you only 4 concepts, like a pod, deployment, and service, and tie off the service. But there's still a lot that yet you have to learn, that you will utilize the Kubernetes cluster for the production, for the real workload. So you have to learn a lot of it. So today I think that I will show you some basic learning about the Kubernetes that you can still learning more, and I think that this is the first step that you are coming to the the high performance load world. So in summary, I can say that Kubernetes is not for everything. If you only develop only the small application that have only no more than 100 or below visitor per day, I think that you should stay with the Docker that's more simple. But if you're looking for the higher the higher performance, higher scale, the higher the production workload that you want to, so I think that you need to learn about the Kubernetes that I showed you today. So thank you so much for today. So if any of you have the question, you can leave it the comment, and I will answer it for you. Or even you can add my Facebook here on the link here. And thank you very much.
All right. Once again, thank you, Jirayut, for presenting. So we do have a few questions from our friends in YouTube. So the first one is actually from Vigilante de la Cruz. So it's actually like this. So is Docker file still be usable when we are already using the manifest file YAML?
Yeah, that is a very good question. This answer is the same as the okay. If we use Kubernetes, we still need to use the Docker. So the answer is you still need both of them. So let's get back to the build ship run again. Here, the Docker file is using to build. So it means that okay, you still need Docker file to build the Docker image and ship it to the Docker registry. And next, you still need the manifest file to doing the infrastructure as code to run on the Kubernetes. So answer is yes. You have to use both Docker file and manifest file.
All right. Another question from Vigilante de la Cruz as well. This one. Yeah. Is there also a concept of pod mapping in Kubernetes, or this is in the container Docker level, on a Docker level?
Okay, that is like a easy question, but very hard to answer because this is the hardest things about the Kubernetes is about the network. If short answer, actually the Kubernetes have its own concept of the pod mapping itself. It is nothing to do with the Docker level. So what you have to learn is about the service type on each map type. We have four service type. For example, is a node pod, is a cluster IP, is the load balancer, and also we have like a external name or external DNS, something like this. I couldn't remember, but this is what you need to learn about how Kubernetes doing the network pod mapping to and map it to the each pod or each container in the Kubernetes cluster. Okay.
All right. I think there's one more final question.
Yeah.
Is persistent data synchronization done automatically in multiple replicas?
Okay. Short answer, no. No. For this, you have to learn about the concept of the persistent volume. They have the concept of the separate the volume data outside the cluster. So basically, I can say that okay, if we have the application running like this, we need to create another resource called the persistent volume or the PV outside of here. And that what the GKE do it for you is going to create the separate disk and then mounting this to the pod. So basically, if this pod is having trouble, if going to something wrong with it, it can move the pod to the other nodes, and then it's going to mount at the same persistent volume. So basically, it's not replication for you, but it's create the separation of the volume for you, and it's mount to the pod for you.
All right. I think there's a final one. It just appeared. So it's actually this one. I've noticed a limitation to GKE. Is there no out-of-the-box dashboard available for the Kubernetes object? This is more.
I really like this
Google.
question, because actually it yes, yeah. I think that the dashboard on here is too it's too small for me. Yeah, we need to know more. So this is the application that I want to recommend it to you, and I use it every day for even on our customer. It's called here the LAN apps. You just search for it on it's called LAN, but you can search that is a LAN app. It's going to read the kube config on your laptop, and let me show you. This is I want to show everyone that okay, please use please use this as a dashboard for everyone. So you will see here, it will show everything, the dashboard as you want. So basically it's not the cluster that I use, but it's not showing anything yet. I think that's because the cluster it is not exist anymore. But let me show you some walkthrough. You can see all the port, or even you can see all the CPU resource. You can see the memory usage on here in real time. So just searching for this, the lane apps, the lanes and apps, and you will see it. And I encourage and recommend everyone to use it.
All right. I think that's it for our question, Jirayut. So I think once again, thank you for speaking about Kubernetes and GKE. So I'll just move it back. All right. So yeah, Justin. So we come to the end of our session today. So before we actually go, I do have some task for you guys as audience to do. First of all, be sure if you have any feedback and if you want to speak, and in the same time, if you have any ideas on what we might want to actually have a new topic on for next month or next few months ahead, you do click on this link. You can't click. You can type in bit.ly/tellgdgc. So you can submit your feedback here, and in the same time, remember to like our page, and which is bit.ly/GDGC-page as well. And I would also like to share. Is it? Okay. I would also like to share that this is our page, and this is Google Developers Space Singapore's page as well. Do like their page. They have a lot of incoming events later on. Yeah, there's a lot. So this is spoiler alert, guys. So there are a lot. And in the same time, we have a global event coming as well, which is Google Cloud on Next on Air. It's actually on July 14th. If you're on Singapore and Malaysia as well, it will be on the Wednesday. Yeah. So be sure to register if you want to know more about what's new on Google Cloud. So yeah, I think that's it for tonight. And once again, thank you, Justin, from Google Developers Space Singapore. And we'll see you guys in the next one.
Yeah.
Bye.
Thank you. Bye.